Hi, and today we'll be looking at 6.3.2 biomechanics numerical model methods. It will be an overview of just the different types of methods we use to measure certain things. Now, firstly, the three main methods we'll be looking at today are preparation, kinetics, and kinematics, measuring force and movement. Firstly, the preparation phase. This is where this is the absolutely necessary step when measuring or doing these methods. You must have a PAR-Q completion, so the participants must go through this questionnaire called a PAR-Q, which just makes sure that they understand certain elements and to make sure that they're safe during the test. Also, it's vital for the participants to warm up before taking part in any test, and they all have the similar warm-ups so that they all get the same amount of preparation. This is just to reduce risk of injury and get the blood pumping around the body a bit more. Also, you must explain to your client what you're going to do or when you're going to do it so that they understand what's going to happen. Um, this this is good so that the test becomes fair and so that they know what is going to come. It prepares them mentally. The second part of the methods, well, we're just going to explain a little session here called kinetics and kinematics. Kinetics are basically the branch of mechanics that mainly deals with forces, and a force is any push or pull on an object. Um, this is this definition was created by Isaac Newton. Um, he literally said forces are any push or pull motion on an object resulting from the object's interaction with other objects. And this is to deal with motion, and calculating motion is to be used in the measurement phase in the second section. Kinematics is basically a motion or movement, and the mechanics of it gives us the equation mass times acceleration equals the kinematic or motion. This will also help us use certain equipment to measure force and to measure motion. That's what we're going to next, which is measuring forces and movements. To measure force, we use force plates. To measure cameras, to measure movements, we use camera. And Bighorn is a special software that allows us to record both at the same time. The force plates are used to calculate how much force is generated. So, for example, when we did the jump test, um, they were used to calculate how much force we put into it, how much our maximum minimum force, and those types of things. And it can also produce a graph, which can be very handy to use when comparing data. We use our cameras to measure, to just as a source of information, so we can make sure that the test was fair and to see the difference in techniques of different participants or whatever it may be. The Bighorn now uses special LED cameras that, sorry, not LED, infrared cameras that record data, and using special objects or Bighorn magnets that you put on your body that will send a signal to the cameras and to the computer, and it can give you a 3D or a 2D image of the person doing the movement, and it will combine with the force plate to produce stuff like force and generated. The next session are the protocols for the vertical jump test. So we did a jump test to see how high two of our participants could jump and comparing them for a power forward role in a basketball team. And we did a counter movement jump and measured angular squat jump. So the counter movement jump, they were allowed to use any technique they wanted to using their hands. to see how much force they could generate and how high they could jump. And we did the measured angular squat jump, so it would be fair, so they all had um, similar circumstances they had to go under. So we did it at two different angles, 45 degrees and 90 degrees. In the 45-degree angle, they had to squat to that angle, and we used the equipment to make sure their knees were bent at 45 degrees and allowed them to thrust themselves upwards. Same thing happened for the 90-degree jump. Before we did these tests, we had to collaborate the equipment so that to ensure the test results would be accurate. So we had to let them measure themselves on the scale first, then we stepped off, then they stepped off, and then when they stepped back on, they were measured and jumped as high as they could. We made sure the test was fair by allowing them to have the similar warm-up routine by using the bikes, and we allowed them to, and we made them make sure they didn't have anything in their pockets to add excess weight or anything, whatever the case may be. So making sure the test is fair is quite important so that the results are very accurate. Something else we also looked at was the video setup and positioning. Now you can get different types of videos that can give you different types of results. You must consider the positioning and distance of an angle from the subject, from the object that you're measuring, so that you get the right accurate results, or whatever it may be. Because perspective error can easily occur if you don't have the camera at a 90-degree angle to the participant on the side you want it for, which goes into stuff like planes and axes of motion. Also, the height and width must be set correctly. You must make sure the height is not too low or too high that you don't capture what you really want to see. So if you have the camera positioned at a certain angle, and when the person jumped, their head left the screen, or their half of their body left the screen, it would be hard to see. Or if you didn't have it angled too high and you couldn't see their feet, which is vital for analysis, that could impede progress or create inaccurate results on the video camera. Also, the size of the image is important, which is similar as well. If it's not long enough, then if it's a sprint or whatever, you might not get the full motion or full test. So it's good to make sure you have the right width or height of the image. The planes of motion are very important when setting up the camera, because depending on what you're recording, you want to see it. So for a jump, you'll want to see the sagittal plane, which allows movement on one half of the body. That's what we're mainly looking at, because if you look at it from the front, we won't get to see what's happening at the side, which is most important in the jump. Also, things such as the frame rate, shutter speed, iris, and focus of the cameras are important. As you can see in the images, the difference. So, for example, the shutter speed, you may not get to see each piece of the wheel, which is harder for it to work properly, and you will produce inaccurate results. Also, the focus and frame rate is very important. Make sure you get the right image or right part of the image you want. Moving on to the planes and axes of motion, there are three different planes and axes. The planes are sagittal, frontal, and transverse. The frontal plane is basically, if you imagine a piece of glass through your body and it's cut, you can only see the front of your body if you're standing in front of someone. That would be the sagittal plane. For example, a cartwheel. That would be a frontal plane, so imagine a cartwheel. Whereas the sagittal is going through the front of your body through the side, so you can only see the side. So if you're standing to the side of someone, as you could see in those jump pictures just now earlier. And the transverse is only the top half or bottom half of your body, so seeing it from a top angle. The axes are different. This is where the body can turn or where movement occurs. There's also transverse, vertical, and sagittal. The transverse axes go through the body, through the stomach, and gives you that cartwheel motion, spinning motion, like if you're on a scuba. The vertical axis goes through your head down to your toes. that is similar. If you're on a skewer, you'll be turning, standing up, just turning around in circles. And the sagittal one goes through the side of your body, which allows a front flip kind of movement. Finally, this is the data analysis that we did in Excel, which will be explained further in my 6.3 analysis video. Thanks for listening.